Hello, I'm Thomas.
And I'm Kat.
Welcome to... Oh, hi. I was like immediately looking away from the camera. Maybe this is just the intro, I don't know.
I think this is the most professional of all of the podcasts. That's what I'm learning.
Anyway, welcome to the pilot episode of the Unstable Fluid podcast. In this episode, we're talking about...
What are we doing? What are we doing, Thomas? What are we going to do?
I mean... this is a pilot episode, we haven't really figured out the format yet.
Well, given that the title has Unstable Fluid Podcast, and we definitely got the podcast bit down, possibly fluids? And maybe my mental state. Was that not
Probably some fluids.
Point?
Probably some fluids, probably some instabilities, probably some physics and maths, because, you know, I am a physicist, but you claim to be a mathematician. Sure.
I am a mathematician. I have a background in number theory. Leave me alone.
Okay. For people who don't know who we are, who are you?
I don't know. No, I'm Kat. I am currently a final year PhD student at the University of Bath in the Department of Mathematical Sciences, studying fluid dynamics. In my other time, I am a Twitch maths communicator, talking about maths on Twitch. That's me. That's what I do. There's like other stuff in there as well, I'm sure, but those are the main two personality traits.
Other than aggressively Welsh.
Oh yeah, that one too. And I like my rugby.
Fair enough.
What about you? Why are you here?
Why am I here? I ask myself that every day. No, I'm Thomas. If it isn't clear from the accent, I'm Scottish. I am an astrophysics. I suppose I'm not a student. I'm currently professionally unemployed at the minute. I've just graduated.
Unemployed astrophysicist.
Yeah, I've just graduated with my master's in astrophysics from the University of St Andrews, and currently in a weird limbo stage before starting a PhD at Cardiff after the summer. I have been studying star formation using sort of numerical simulations, and after the summer I will be doing galaxy simulations, which is a wonderfully different bit of astronomy, but fundamentally similar work.
Okay.
Aside from all of that, I do YouTube videos about space normally, and I'm nominally a science communicator on Twitch, but a lot of the time it's just strategy games because I don't have enough time.
That's reasonable. There's strategies in science. I'm sure. Can you talk about the science of strategy games?
I think there are just a lot of physicists that play a lot of strategy games when they should be doing physics.
Ah, that one.
Yeah. Though I don't know, I argue KSP is relevant, Kerbal Space Program. I argue it's relevant enough.
It has the word space in the title. I think you're doing well.
Yeah, it's applied orbital mechanics.
It could definitely be worse.
Yeah, it could be. Could be a lot worse. Wait, we covered who we are. We haven't really covered what this all is, the whole podcast thing.
Oh, this isn't my therapy session?
No, I think you're in the wrong place.
Never mind. So what are we doing?
I think so. I mean, this has been, I think we've been trying to do for a very long time, and, you know, both being busy have not got to it. But we decided basically that a podcast, you know, we're people on the internet that like the sense of our own voices, so we might as well start a podcast.
I like talking nonsense at a camera. I do not like the sound of my own voice.
Okay,
you think I'm
what
listening back to any of this?
Fair enough. It is me that's doing the editing. Yeah, the big idea behind the podcast is that we want to have a sort of more open discussion about physics and maths because we think they're cool, but also a bit about academia because there's this whole preconception that people in universities aren't real people, and trust us, they are just as dysfunctional as everyone else. Possibly more so.
We have all the same problems. It's all good.
And then we go and make them worse by being in academia.
No, there are some good bits of academia that don't get highlighted, and there are some bad bits that we all pretend don't exist. And giving her an authentic, like, our perception on what it is, I think is something that needs more of in the internet, which is why screaming into the void in this way might be useful. So, yeah, hopefully you like some of our nonsensical opinions and or real life experience. So, also, like, maths is cool.
Physics is better.
I disagree.
I know. The general plan is that we'll have some talking about science. Yeah, general plan. Thank you. The general plan is that we will have some physics, some math, a lot of science. We'll then talk a bit about academia, and segments of the podcast will probably develop as we come up with them. There will possibly occasionally be guests, but we haven't asked anyone yet, so don't quote me on that.
That's gonna be the tagline. It's Unstable Fluid Podcast. There may occasionally be guests. Don't quote me on that.
Honestly, might add that to like the banner on like YouTube and stuff.
I think it's true to form. It accurately portrays what we're trying to put out and highlights how much of a chaotic mess this is.
I mean, yeah. Anyway, the name. I sort of came up with the name as a joke, and you thought I like that.
I feel like it was the most accurate thing for if we want to talk about an authentic academic experience, and the only overlap between our subjects, because maths and physics are sufficiently different, is the fluid dynamics. Then it fits quite nicely. I think there's also an element of like fluids are inherently unstable. And you know,
the fluid dynamicist.
Yes, but it's a pun, right? And I like puns.
Puns are good.
That's the crux of it.
Yeah, it works on several levels.
It do. And if we get the opportunity to talk about fluid dynamics specifically, I will quite happily fill the entire podcast with that. Although I will rescind my opinions about different fluid phenomena just because I've already had enough of the internet telling me I'm wrong on that one. Thank you very much.
Kat, what's your opinions on turbulence?
It had to go somewhere, okay? Context for this, I made a video with the wonderful Dr. Simon Clark about fluid phenomena, and I ranked them, and apparently having an opinion is bad. Look, if you
having an opinion is fine, having the wrong opinion is bad.
Welcome to academia. If you had to populate, what phenomena would you put in F tier then? What would you like drop?
Honestly, like laminar flow is boring.
But that's the build, like, okay, but the two building blocks and like I think this actually, I raise you, if you divided everyone, the mathematicians would like laminar flow more and the physicists would like turbulence more. So much of what we do builds off a laminar assumption. All of my models, everything that I do when it comes to like making nice reductions and like assumptions about the system, all assume laminar flow. Whereas like if you're looking at a big messy system and you can do like all of the coding and all of the like, you don't care about the nitty gritty details, turbulence is where you kind of start. I think that's the dividing line.
It probably is. I mean, I do numerical simulations and I was just like, yeah, because I'm running on large scale codes that frankly I didn't write. I just be like, oh yeah, turbulence, it's there. Deal with it. Mm-hmm. And if something doesn't really work, you're either blaming it on turbulence or magnetic fields.
Okay, these are two things that I don't even begin to consider.
We'll get to them at some point. But anyway, we seem to have like launched into fluid dynamics. Kat, do you want to explain what your science is, other than just maths, allegedly?
It is maths, thank you very much. I like equations. I think my grandfather always used to say that, like, I do sums. How are the sums going? And I'm like, the sums are going well, thank you. I showed 2 = 2. It's all good.
I mean, isn't the proof for that quite hard?
You can confuse people by showing that 1 = 2. This is a fact. But that is just mathematically wrong. And if you want me to rant about that, I will.
Not today.
But that's not my research. My research is not looking at why 1 = 2 or the converse. So I study a phenomena called bouncing droplets, which is kind of exactly what it sounds like. So when you have small drops of like water or just any liquid really falling through the air, there's obviously like some level of air resistance happening and whatever. But as it approaches a surface, the air between the droplet and the surface kind of gets pushed out of the way. And then what will happen is as soon as the two touch, the air layer like fully depletes and surface tension effects take over and cool stuff happens. If the surface the droplet is falling towards is liquid, instead of just like being a full resistance, it kind of moves out of the way a little bit. And what can happen is in the right like size and speed of everything, what am I trying to say? The big pool surface can act as a trampoline and kick the droplet upwards and cause it to bounce. And I spend basically all day, every day, thinking about something that happens in like less than a second. That's what I do. It's just this one bouncing droplet. But the maths of it is really complicated, knowing exactly what's happening, where the pressure is, what the pressure looks like, what the velocity of the fluids involved are doing.
Okay, I'm going to ask the question that no scientist ever wants to hear the question of.
No, I refuse. Go on.
What is the real world application of this?
Okay, so welcome to maths. Basically, directly, there isn't one. But this is directly in the same way that when you are sat in maths class when you're in high school and your teacher's teaching you trig and you're like, why would I ever need to know this? And the answer is because you need to pass your exam, or because, maybe you'll need to build a house. I don't know. Whatever teacher your answer gives you when you say, why do I need to know trig functions?
Whatever teacher your answer gives you.
Whatever answer... whatever answer your teacher... whatever answer your teacher gives you, it's really hard to kind of see that actual connection until you have to use it. And with the sort of fluid dynamics that I'm doing, with the sort of research that I'm doing, it's sort of on the edge of pure, like, theoretical maths, not pure maths, theoretical maths. And is there a direct, like, if we can figure out how a droplet bounces, we're going to solve world hunger? No. But the theories and the models that I'm creating and the techniques that I'm using could be used on a broad variety of things. That, coupled with the fact that, like, having a better understanding of how something works will mean that we're more able to use it in the future. So understanding how liquid impacts, which is what the sort of broader regime is called, or solid liquid impacts, how those happen can better improve, like, engineering processes. The real world examples that we always jump to are, like, in the very, very large scale. They use the stuff that I'm doing, or the precursor to the stuff that I'm doing, to model how planes could land on water. On the opposite end, we use an understanding of how a droplet's going to hit a solid surface to design inkjet printing. So, like, is my specific little niche going to, revolutionize the world? No, but it's going to add to a big portfolio of things that are slowly improving everything, hopefully.
I suppose that is what they say about academia, and specifically, like, doing a PhD, is if you consider like a sphere of all knowledge, your job doing the PhD is to just, like, try and just push, like, a little dent in the outside of that sphere, just push it just that little bit further. And yeah, it's like this sort of thing of, like, yes, it's a tiny bit of a much larger research field, but everyone's is that. And eventually, after all of that cumulative stuff, somebody comes along with something that's, like, actually useful or revolutionary in the field. Like, I don't know, like, every like Nobel Prize winner, or I guess for maths, the Fields Medal, I do know that one at least.
Well done. Yeah.
Like, every Nobel Prize winner, yes, they've got a Nobel Prize for something, but almost none of them could have done that without there being, like, a massive backlog of stuff. Like, yeah, I don't know. I've been making videos recently about the 2020 Nobel Prize in Physics, which was the one for the discovery of the supermassive black hole at the center of the galaxy.
Oh, cool. Yeah.
So, like, yeah, that's a really cool discovery, but that couldn't happen without all of the instrumentation that made the telescopes that made it possible. It couldn't have happened without all the theory work in the background that were like, yeah, black holes should exist, and this is the size, that if you've got this much mass in this area, that is the only thing that can really be there. It couldn't have happened without, like, 1600s, I think, Kepler coming out, I think it's 1600s, Kepler coming up with, like, his laws of planetary motion and being like, right, okay, so we're seeing that, which means that mass has to be insanely large, because that's how they found it, was, like, looking at these stars that don't move normally. But without all of this backlog of stuff, they couldn't have got this Nobel Prize winning discovery. Like, it obviously has to be based on a massive backlog of stuff that other people have done.
Yeah, exactly. I mean, look at the reference list on any paper ever. And
it's insane.
It's Yeah. I think the biggest one, like, and honestly, if you want a field day, go look through a thesis because it's literally hundreds of references. It's hundreds of different people's work.
I've seen theses with like bibliographies longer than some chapters.
No, definitely, because it's not possible without all of those papers. Like that's not to say that every PhD student has read in depth every single word on every single page of all of those papers.
Oh no, there is not time for that.
No, ain't nobody got time for that. But even just like skimming through and checking, one of my favorite things to do when I pick up a new paper is A, look at the pretty pictures.
Obviously. Yep.
Hands down, that's the first thing. And B, check over the like equations. Just be like, is this in the same ballpark of what I'm working in? And then I'll go back and read the introduction, or I might read the conclusion first. Honestly, we could do a whole thing about how to read a paper.
Oh, we probably will, but not in today's episode.
Fine. What do you mean this isn't just an unthought of train of consciousness?
We've got to have something for future episodes.
Yeah, the pilot episode isn't going to be 4 days long then.
No.
Fine.
So essentially, if you could summarize your research in like a sentence, what would it be?
Understanding why and how drops go boing on liquid surfaces. That's the thesis title.
I really want that to be your thesis title.
I think I can sneak it in as like a informal one on the info page. You know when you do like the movie title, or as it's like colloquially known, actual movie title. I'll do something like that. I think my formal title is going to be much more fancy.
It's fine. Nobody ever reads a thesis anyway.
Hey. Hopefully my supervisor will read it at least once.
But your supervisor and your examiners, and that's probably going to be about it.
Yeah. I don't know. Maybe the listeners will want to read it.
I tried reading Simon's at one point and gave up.
I skimmed to the pretty pictures. So what do you do? You're obviously like between. Yeah. What is astro space stuff?
What is astrospace stuff? Good question. I mean, apart from like, apparently the reason that like loads of people got into science even if they didn't do astronomy, the stuff that I specifically do is I don't do telescopes. I realize I've just said the stuff I do is that I don't do telescopes, which is fine.
Is it like either or in space?
Okay, you've got some people that only do telescopes. And then within that, you've got people that use the telescopes and people that make the telescopes. Like there is an entire field in astronomy called instrumentation, which is people that it's basically developing new either detectors or telescope systems or whatever. So there's like huge instrumentation teams that are like in charge of each of the instruments on like the new newish JWST. But yeah, so that's instrumentation. Then you get observers. They're the ones that use the telescopes, get a load of data and process that. And then you have people like me who are honestly best described as either theoretical astrophysicists or computational astrophysicists. I would probably say that I land on theoretical computation, so combine the two. Because the stuff that I do is rather hard to observe. So I say the stuff that I've done for my master's project is incredibly hard to observe, because what I did in my master's project is I was using numerical simulations on big supercomputers at the university, running fluid codes. See, we're getting back to fluids.
Hey.
So running fluid codes that I'm sure I will explain in another episode more in detail. Looking at a process called accretion, which it's a fluids process that through the viscosity of the fluid, so how much it sticks to itself, matter in a disk can flow inwards through that disk and fall onto stars, or black holes, or supermassive black holes. It's how stars form. It's how black holes are fed. You may have heard of something called a quasar. It's an astrophysical object. Kurzgesagt actually made a video on it recently, and they described it as a galaxy killer, and that is exactly what a quasar is. You've got this huge accretion disk around the black hole, and because everything's falling into this black hole and it gets really fast, it gets really hot with all the dynamical friction going on, and it gives out masses of energy. I wasn't doing that. I was simulating systems of 3 stars accreting small amounts of mass to see how they grow and see how changing like the relative masses of those stars affected how they accreted that mass. Like my triple systems have 3 stars in them, why they're called triple systems, and they're an arrangement of 2 stars close to each other in what's called a binary system, where it's 2 stars orbiting each other with another star much further away. So, and then that binary system and the single star are in a much wider outer binary system, a wider binary system. So what I was looking at was when you change all these mass ratios, which stars take the most mass and angular momentum and all sorts, and how does it affect the accretion processes, was what I was looking at, rather than say, how does accretion work? Because we kind of understand that pretty well.
Okay, so what's the answer?
The answer is that, so the highest your ratio can be is 1. They are the masses are equal, because a ratio is just one thing divided by another, gives you a number at the end of it. So the largest your ratio can be is 1. So you've got your, I'm just going to talk about a binary system. You've got your 2 stars as being the same mass. As you decrease that ratio, decreasing it from 1, one of the stars becomes larger compared to the other one. And what happens in these accreting systems is that because of how orbital mechanics works, there's a center of mass point between these 2 stars. And when your ratio becomes less than 1, the heavier star gets closer to that point and the lighter star gets further away. And because it's further away, it's closer to the gas in the disk and it starts getting more of the mass. So the lower your ratio goes, the more mass gets onto that smaller star. And over a very long period of time, the stars would trend towards mass equalization. So they'd trend towards having a ratio of 1.
Okay. Would that be like, would it oscillate? Would they like swap and then kind of go back and forth past equilibrium? Or would it kind of be like small and then they stabilize at 1?
It would probably depend on how much mass inflow you've got. It's a relatively slow process in terms of it. Like it's not like you're gonna get from basically nothing to 10 solar masses in like a year and a half. It's not gonna happen that fast. But at the same time, it's a very fast process on astronomical scales, because what we term as fast on astronomical scales is about 100,000 years.
Right.
So this is what I mean when I say that what I do is hard to observe. So this is the problem we have in astronomy, is that almost everything in astronomy is not fast on human timescales. So you've got like stars taking millions, if not billions of years to like burn through their entire lifespan. So to get ideas of how things happen in astronomy, we have to look for the same object in different places in the universe to see them at different points in their life cycle. So you can then sort of extrapolate from those various points of what the overall evolution is. Okay.
Yeah, that makes a lot of sense, actually. You're kind of seeing different snapshots and you just kind of hope that they all match up and fill in the gaps.
And there are some gaps that we don't fully understand yet, obviously, otherwise we wouldn't still be doing astrophysics. Like, it's a process, and if we knew everything, we just wouldn't do it anymore.
Yeah, I think there's almost naivety to assume that you know everything about a certain thing. I think the more you know about something, what's the saying? The more you know you don't.
Yeah, it's like the whole Dunning-Kruger effect.
Yeah. Yes.
That sort of thing, like knowledge versus confidence. That like if you know basically nothing, if you know like a little, you think you get like really confident that you know everything, and then you learn a little bit more, and then it just collapses. It's like, oh, I know absolutely nothing, and then you slowly start working your way back up the hill again.
Yeah. So I think a PhD sits right at that second valley of like, we know nothing. Well, we know more than some people, but our confidence is like, yeah.
I suppose it's like you get to the end of your undergrad and you think you know stuff, and then you start a PhD and it's just like, oh no.
Yeah, I thought I was top dog when I finished the undergrad, and then I did some master's level courses in statistics, and nope.
I mean, that was your fault for doing a statistics module.
It might, okay, but I would argue that it was good it's good experience because now I know, like, at the very least, when people say an expectation, I kind of know what they mean. But also, it was a bit of maths that I'd never kind of done before, and I wanted to check that I liked the bit that I was doing. And the answer was yes.
I mean, to be fair, I can't really criticize. I tried to do general relativity, and that nearly killed my degree classification.
Oh. I mean, you can't have... You can. People do be fantastic in every module, but, like, there's nothing wrong with being like, this is my strength and this is not. Yeah. It was actually a very interesting conversation I had with my undergrad personal tutor when I was looking at PhD schemes, because I was one of these people where, like, the modules that I was good in, I was good in, I worked hard in, and I worked hard across my whole degree. I'm not putting that out there. But I had modules that I excelled in, and I had modules that I was really struggling with. And it's something that came up in interviews was, why did you not do well in these other modules? And it's a really hard thing to be like. It makes the successes that you do have feel not enough. But that is nonsense, because you can sell your strengths. Like, if you're going for a job in computer programming, no one's going to ask you why you can't write me a beautiful English literature essay. You don't need it, therefore focus on the things that you do have and you can do.
Yeah, I think that's definitely a thing. Like, there's this sort of expectation that people who do well at some things should be good at doing just about everything. I think it probably comes from the fact that, like, people who are smart in school tend to be good at everything, as opposed to just being good at a couple of things.
Yeah.
And then you start getting to more specialist stuff and find that you're not good at everything, or that you actually just then, if there's stuff you don't particularly like, you don't put in as much effort on it. Like, I don't know, I've had to do a module on like electromagnetism. And, like, I just don't like it. Like, the maths that was in part of it, and this will make you happy, the maths that was in the parts of it, like all the vector calculus stuff that was part of EM, really like that. Hell, I audited a vector calculus module in my second year because I couldn't take it. But, like, I didn't like really care about the subject, so I just didn't really try, and then had to try and cram it all in ahead of the exam, which, like, worked out, but I was ultimately incredibly shocked that I did well in the exam.
Yeah. And I think there's something to be said as well of, like, if doing good in school, there's a level where at like high school level, you're learning to pass exams with, like, different techniques, not necessarily learning, like, how to be a good person in that field. Like, the difference between a maths exam at GCSE and A level, where you're learning all these, like, basic techniques and you're building up a portfolio of this is how you kind of solve these specific problems, versus undergraduate, where you start getting, like, here's a problem you've literally never seen before. Go use your critical thinking skills to try and figure out how it's done. It's a different thing, and it's a different technique, and it's a different way of, like, thinking.
Yeah, definitely. There's something that will always stick with me that I got told by a director of teaching in physics at St Andrews, which was that they're not that interested in our ability to, like, regurgitate facts. Like, the bookwork questions on the exam are going to be maybe 10% of the paper, maybe 15 at a push. What they're aiming to do when they're teaching us at uni is they're trying to teach us how to think like physicists or mathematicians or whatever it is you happen to be studying. They're trying to get you to develop those skills to make you a good physicist rather than a good fact regurgitation machine. I mean, it's something that I presume is similar for maths, but for physics anyway, there's a whole aspect of they know that most people will do a physics degree and then will go on to do something not directly related to their physics degree. But at the same time, physics degrees are some of the most employable degrees because the things that you learn doing them, not the facts, but how to approach a problem, how to think it through logically from, like, first principles, from the very basics, and build up a solution from there, are just really useful. I guess they'd call them soft skills. I hate the phrase soft skills.
I think
really
it makes it feel like they're not as important. And when you put like communication in there, no. Yeah, trying to think of a word, an alternate for soft skills though. Because you have like
we have a module at St Andrews in physics called transferable skills for physicists, and I think that's a way better phrase for it.
Oh, I love that. Yes, that's fun. That's exactly it.
Like I much prefer the phrase transferable skills to soft skills. It's just it feels like it makes them something in their own right, as opposed to like the B team to all the stuff you learn in your degree.
Yeah, and it's also the things that are, as you say, transferable to other subjects and other parts of your life, whereas the core knowledge is more direct. I think there's an interesting point about different universities to be made there that maybe won't get into the episode because I'll say something derogatory, but like I noticed different institutions prepare their students for different career paths. And
Definitely.
That's not a bad thing. But for example, in my undergrad at Cardiff, the kind of known assumption was that most people were not going to stay on in academia. So we had a lot more modules that, as you say, were transferable skills. They offered 2 different modules on teaching, for example. Financial maths was a much bigger part of the offering. Whereas now I'm a PhD student in Bath, and the percentage of the students that stay on to master's level even is much bigger. And there's definitely an argument to be made there that we as the workforce are being forced into having more experience at a younger age and having masters, like having a higher level of degree to get a job that you wouldn't have needed it for previously. Like there is definitely a push from industry to hire people who have like the best degrees, and that's inflating the number of students going to the higher level. So it could be a passage of time thing, but even when I was in undergrad to other undergrads, the difference there was more people going to master's level. Therefore, a lot of the subjects were a lot more sort of, I'm going to say pure maths, but I mean just maths, not like analysis.
Yeah.
That they don't have as much of an offering for those sorts of transferable skills as in contrast with Cardiff. And I think that was kind of similar. You could look at different institutions and kind of see where their workforce went and then what skills they were being prepared with. And I wonder which part of that cycle is the chicken and which part is the egg. I
totally get what you're saying about the whole different attitudes of different institutions. Because I mean, I have friends that, I have friends at St Andrews. I have friends that went to a number of universities in Scotland. Being Scottish, we didn't really look outside Scotland because our tuition fees are 0 for the first degree. But I have friends that went to a range of different universities in Scotland. So you've got mostly St Andrews, Glasgow, Strathclyde, and Dundee. And that covers the breadth of perceived prestige of the universities. It covers the very academic through to the like far more vocational, well, maybe not vocational, but far more sort of applied level of degrees, where you've got sort of St Andrews at the very academic end, and then you've got like Strathclyde, which is very much engineering focus, business focus, and I agree. There's certainly differences in how different universities approach it, and I think that there's I don't know if it happens like consciously or unconsciously. I think it certainly depends on like the students within the university, but also on the staff. So something that I've experienced a lot in St Andrews, specifically in the physics department, but it seems fairly general, is that when staff are open to student feedback, the courses tend to be a lot more based on what the students are interested in. So, I mean, the best example I have in physics is like the computational parts of our degrees. 10 years ago, there wasn't that much computing in a St Andrews physics degree, but the number of people that leave physics degrees and go on to do software development, engineering work, working in finance, and they need the ability to code.
Yeah.
There's there was this whole shift. There's now like a computational physics module in the St Andrews physics degree because students were like, we want this. And then they started using it. They started making this module and they started using a programming language called Mathematica, which it's really only used by like theoretical physicists, as far as I can figure out. It maybe is used by some mathematicians because it's got the whole symbolic integration stuff.
It's in there, yeah. It's in the dark depth realm of use. Anytime someone is like, using Mathematica, it's sort of salute to you, leave me alone, don't ask me any questions.
Yeah, it's a pretty specialized language, and it's one that I had to learn for this module. But after several years of people complaining about it, they've now switched the module over to Python because we're like, Mathematica is useless unless, in physics anyway, Mathematica is pretty useless unless you're going to go in to do theoretical physics academia. It's like if you're doing like people doing theoretical physics master's projects used it all the time.
Yeah.
Everybody in astronomy had to go, we got taught Fortran, which is similar to C++. They got taught Fortran and then just had to figure out Python because we needed Python for our master's projects. And so did all the experimental physicists. They either needed to learn Python or MATLAB.
There's definitely an argument to be made about teaching undergrads programming languages that are behind a paywall as well. As you say, going out into the workforce, if that ever happens to be, you're then having to switch. And, you know, coding languages, there is an innate level of if you can think algorithmically, you can jump between them quite nicely, but you're still giving people not the head start that they could be having. That, and also it's blinking expensive. And it's a shame because MATLAB is a great language and I really like it. So do with that what you will.
No, as far as I know, it's there's nothing wrong with it as a programming language. The problem is that it's behind a paywall and that's something you have to deal with if you want to use it. And most people can't really use MATLAB unless they're willing to pay for it themselves or have it paid for by a university or an employer. But you're currently within academia doing your PhD and I am starting mine in October. So I thought maybe we should have a little bit of a chat about like how we decided to like do a PhD, how we got to the point of like the things we did before the applications, and then how getting a PhD place actually kind of is in reality, because it's very different from undergrad. It's not just you fill out a UCAS form and wait for universities to say, yes, we'd like to give you a place.
Yeah, so PhDs applications are much more free-form and open to the university. The one
which makes
that
them
I
variable
remember,
and really irritating.
Yep. Be prepared to rewrite your cover letter and your CV like 20 times. I think it gives a much more realistic approach to like what applying for a job kind of looks like, in that not every company has the same standard or is looking for the same thing when it comes to that. Some places want references immediately, some don't want them until they actually want to consider you. So yeah, PhDs application process. The university will typically have a sort of standard input for like all PhDs across the entire uni, but typically before that, you would have to reach out to either a supervisor or a training program. The one that stands out to me was, so my training program, I'm part of the Statistical Applied Maths at Bath, SAMBA, Centre of Doctoral Training. And their website on their application, I think it used to be, drop an email to Susie. Here's the email. And that was it. And that was how you kind of got the ball rolling, was you just like, I'll just like send an email expressing interest. And it was very chill. And that was all the information you were given. I think it was like 250 words explaining why you want to join, maybe. Like it was, it could have been done in a Google form. And I just remember seeing that and the fear inside of me of like, what are they asking for? Is this a trick? Hi, I want to do a PhD. Like, what do they want? And
I presume this is fairly similar to like a physicist attitude to career advisors who are like, oh, you could do this, you could do that. And we're like, no, just give us instructions. What do we do?
Yeah. It was very like, I would like a little box to tick exercise. Thank you very much. I don't don't know what I'm doing. So
Ask me questions, I can give you answers.
Yeah. And I think being like behind the curtain now, I'm realizing that they just want to see like who you are, what you do, and like what your vibe is. Honestly, like a lot of it is a vibe check, especially with a training program where you're joining a big cohort and the interplay of like how you work with other people is part of your training. And that's not to say it's like one of those like personality tests by any means, but it's just like, can you explain to us why you want to be there? And it was very informal because it was very informal. It wasn't a trick to try and catch you.
Yeah, it's very similar to how I've always described like the personal statement for for applying to undergrad, of like they're like an admissions person can see your grades and knows this person is good at the subject they're applying to, but the personal statement is the bit that like convinces them that you are a person, because they're not just looking for good physicists or good mathematicians or computer scientists or whatever other degree you're applying for. They're looking for at least semi-functional humans, who are the sort of people who are going to get involved in things in the department or things at the university that will be able to work with other people and contribute to that sort of wider academic community and culture. That's a really important thing. And you can't get that from this person has 5 A's at their hires, which is the Scottish qualification, not important. It's the one we use for getting into uni.
Yeah. I think that kind of goes back to what I was saying about the way that academia looks at their staff. Is like you have research, but you also have teaching, and then you have this like other stuff. And the other stuff is like, do you contribute to the culture in the department? Are you going to volunteer for things? Are you going to start your own initiatives? Are you going to, make an impact? And that's sort of at a much less intense level, kind of what they're thinking about with a PhD is you have your supervisor is going to be the person that cares about, can you do the work? That is going to be the only person on that examining board that's going to care, like, can you physically complete the research that I want you to do? The other people are going to be looking at, sort of what do you bring to the table? Yeah, just the human bits around what makes you you. And I think more often than not, telling an interesting story or just being a bit more honest about it. Like it is a skill, I think. Applying for a job or applying for a PhD, applying for anything is a skill, because fundamentally you have to market yourself in this way that is like not lying, but having absolutely no imposter syndrome. Or at the very least, that's what you want to present. You want to present the very best version of you that you can be, because everyone else on that table, in that stack of personal statements, is going to be doing the same thing. So you have to really, really, I don't want to say embellish, because that's just not what I mean, but you just have to be very confident, and that can be quite scary, especially as someone with like maybe doesn't have that all the time. It's really intimidating, but that's sort of what you need to get across. Luckily, interviews, I think, well, I don't know. What was your opinion on interviews? You've done them more recently than me.
Yeah, I totally say I agree with like sort of thing of like having to try and I don't even like not embellish what you do. But I guess the best way I can describe it is like you've got to make sure you own your wins. Like be very like very much feel like I am good at this stuff, and just like there's this whole thing. It's a very I don't want to say British thing because I don't identify with that, but like, you know, that sort of culture of like, oh, it's like I can do this, but I mean it's fine. It's a bit like a whole self-deprecating thing.
Yes,
that people here tend to do.
I don't know what you possibly mean.
I know what am I on about, but it's that sort of thing of like trying to like disengage that part that's so ingrained in so many of us to be a bit self-deprecating, to put ourselves down. But yeah, as far as like the interview stage, yeah, I certainly I had a few. How many did I have? 5 interviews. Right. Okay. I had 5 interviews at 4 different institutions. So I had my PhD interviews. I had Cambridge, Oxford, St Andrews, and then there was 2 different funding pots at Cardiff that I interviewed separately for. And none of these interviews were the same.
Yes.
They were all different in different ways. Cambridge, like, I don't know. I feel like Cambridge tried tried to make it feel really informal, but it was my first one and I was really nervous.
Okay.
And I think like I feel like the way an interview works varies depending on what they're looking for. Like you can have the really serious interviews that like Oxford was like the most serious one that I had. Like they gave us papers to read that we would discuss in the interview level of formality, and it's certainly a difficult thing to try and perform. You are performing in an interview. You're trying to put forward the best version of yourself while also trying to make it look like you're not performing. And I don't know. There's this whole stereotype of physicists and mathematicians being rather socially awkward. It is entirely deserved. I mean, am I wrong? And trying to get through that sort of trying to get past that to make yourself seem like really good to these universities is tricky. And it actually ended up the PhD place that I got was my final interview.
Mm-hmm.
It was the last one. I think it took that long for me to get comfortable doing it. But at the same time, it's trying to, you're also trying to do all these interviews, but trying not to get too bogged down with, was it good? Was it bad? Oh, I think I screwed that up. Oh, that maybe wasn't what they were asking. That sort of second guessing yourself through the whole thing. Yeah. And that's really tricky. And especially when, like, if you've not finished your interviews and you start getting like rejection letters through, that's really hard to do. And I think in the end that now that I've got a PhD place and now looking back at all of them, it now makes perfect sense that the one that I got is the one that it makes sense that I got the one that I've got, because I'm like Kat going to be going into a into a Centre for Doctoral Training. Yeah, CDT. And mine is the one I'm going to. It's one that's based in, it's 4 Welsh universities and Bristol. It's AI
so
machine
5
learning.
Welsh universities.
And
Bristol's honorary Wales. Have you ever been there? They say lush unironically, like they are basically one of us.
I don't remember the last time I was in Bristol beyond sitting in a train at the train station.
Ah, okay. Yeah. The joke is it's part of Wales. It's
okay.
It's close enough to home that it feels like home for me. So
okay.
Yeah.
But yeah.
Sorry,
So
continue.
So it's AI, machine learning, and advanced computing. And considering that, as I said before, I'm a computational theoretical astrophysicist, it makes perfect sense that I got offered a PhD place for an advanced computing AI CDT. That makes perfect sense.
Yeah. So did you feel like, as an isolated incident, that interview went really well? Went really well then?
I don't know. It was the most. So the interview for the AIM-like CDT, the one that I got, it was different because it was on Zoom. The rest of them I'd done in person.
Ah, okay.
Because like fundamentally I didn't want to go and accept a place at a university that I'd never been to the place before, never actually seen the place.
Yeah.
So when the interviews came through, I was like, right, I am going to go down to Cambridge for the interview. I'm going to go down to Oxford for the interview. St Andrews, I was obviously already here. And then for my first Cardiff interview for the STFC funding pot, the UK Research Council's directly funded PhD place, I went down to Cardiff for that one. So I'd been to all of the departments in person, done all those interviews in person, and then I got the interview for the AIM-like CDT at Cardiff, and I was like, well, I've been down, I'm not going to go down again. Yeah. So I did that interview on Zoom, and I don't know if it was maybe that I'd had time to reflect on the previous ones because it was maybe a month or so later. I don't know if I just had more time to reflect on it, or it was the fact that I think what certainly helped me when talking about the research was that I was at the end of my project rather than smack bang in the middle waiting on data. Like all my in-person interviews, they'd say, oh, what results have you got? I'm like, well, I don't have my results yet. My code is currently running on the computers in St Andrews. It will be waiting for me when I get back, but it's not ready yet. Whereas for the Cardiff one, I could, for the Cardiff CDT, I could like actually talk about my results and talk about the project as a whole and actually make it sound like I knew what I was on about.
Yeah, I mean, that's like an
I
interesting
think maybe
point.
It was a factor of just it being later.
Yeah, I think it's an interesting point that the applications typically open in, I think, as early as like October, at which point
the deadlines are normally sort of December, January.
Yeah. Some places do extend all the way to March. But yeah, if you're going straight from undergraduate into a PhD scheme, you're going to be applying for these positions before you finish your final year. And typically, like, most institutions will only sort of introduce a research project in the final year. So you might have done 2 weeks of research and you're expected to interview talking about how you want to do research. Like, it's not an accurate representation of your ability as a researcher. That is to say, actually, there's an interesting shift and I think an awareness of, if you do decide to not go into a PhD straight from a master's project and you go outside the industry or you go work in the field, there is nothing stopping you coming back. And actually,
oh yeah, definitely.
The people that kind of have, at the very least, a slightly more chill interview, I notice, they seem a lot more confident, and maybe it's because they've gone through like workforce interviews beforehand. They come back because they can talk about their experience as a finished, complete product. They can talk about their undergraduate degree, or a research project that they've done in industry, or just sort of what they bring to the table in a much more complete, finalized way than someone like us going in and being like, I will have done this, hopefully at some point.
Or having to talk about like summer research projects as well.
Yeah, that's even if you can get one.
Yeah.
Because not every institution offers that sort of thing. It's
not everyone can afford to do them.
Exactly. It's an interesting thing, and actually one of the underrepresented groups that people consider when they look at PhD applications is kind of late stage career. You have they're called mature students when you go into it at undergrad, but like that sort of vibe, but for PhD, is still like some of the best researchers I know are the people that went and did XYZ jobs beforehand and then came into it, because they kind of had a more they have better work ethic than those of us that have come straight from undergrad, where we used to stay up till 4 a.m. drinking like Monster and revising last minute.
I feel like you're betraying a lot about your undergrad, Kat, but
I figured it out eventually. I think that jumping back, because I keep segueing because I do not have an attention span.
Sorry, what's the attention span?
PhD, exactly. PhD interviews are, I think they're always going to be scary, and if you're not like at least a little bit nervous, like, tell me your secrets.
Yeah, I'd like to know as well.
But
if you'd like to tell us, you can email us.
Yeah. But it's that thing of, you have to be authentic. And also the thing that I didn't appreciate until I went for an interview. So one of my interviews, I ended up interviewing with a different academic than the one that I'd applied to.
Right.
Because the one that I'd applied to was not taking on anyone else. But I wasn't told this until I was in the room. Fundamentally, I realized at that point, I didn't want that PhD. And at which point the interview becomes what it always should have been, which is they're interviewing me to see if I can do it. I'm interviewing them to see if I want to do it.
Yeah.
And I was asking questions and kind of engaging a lot more when you finish an interview and they're like, oh, any questions for us? It's like, yeah, I do. I want to know why I should even consider this. Like, I want to know what the culture is like. I want to know what opportunities you have, because I don't know, like, what sort of, is there money for conferences? Is there an ability for me to work with other people? Do you offer, like, placements? Do you support students in doing extracurricular activities? Like, what... You're interviewing the supervisor and the institution as much as they're interviewing you.
Oh, yeah,
and
definitely.
It feels like egotistical to say that, but yeah, you are a commodity, and like, you have something to give them as much as they have to give you.
Exactly.
And if you can frame it in that way before you get in the room, you'll feel a lot better about it. But yeah, it gave me that perspective then going into all my other interviews of like, I'm going to ask the questions that I actually want answered. And if they don't like where I'm coming from, it's not the right fit. And I don't want to spend 4 years of my life doing something that will not make me happy. Because there will be a point in the PhD, if you do one, that you hate your project. There'll be a point where you don't like your supervisor very much. Hopefully those two things don't happen at the same time.
Hopefully not,
is always the goal. But you need to kind of enjoy the other aspects of it, or like the concept of it enough to get you through that rough middle bit that typically comes about just after halfway through. And like, luckily for me, as part of like my project now, I have a fantastic cohort. I have really, really, really strong support network in place by design of my training center.
And that's something you've got to look for.
Yes, yeah. And that was such a big part for me, because I'm like, I don't think I'm a people person necessarily, but I'm a very small number of people person. So having that infrastructure in place that I can we vent to each other, and like I know who I can talk to about issues I'm having, and being able to kind of be honest about the things that I'm struggling with. That was very important to me. So an environment where everyone keeps to themselves and we don't share that we're struggling, I will just internalize it all and feel worse. So I know I can't fit in those environments, and I don't want to.
Yeah.
But it's figuring out what works for you. Like, if you don't want someone coming and telling you all of their problems, maybe don't join my office. But it's figuring out what works for you, and realizing that you're allowed to ask for that accommodation.
Yeah.
As much as they are allowed to ask you for, what technical ability you have, or why are you applying for a stats CDT when you haven't done any stats. Valid questions.
It is very much, as much as it seems really weird to say, it is a vibe check.
It's definitely a vibe check.
There's that sort of unquantifiable thing that, like, I realize that vibe check is basically just a replacement term for gut feeling, but I've said this many times before when we were talking about like how I chose to come to St Andrews, is like, I had in my head, I was like, I can't pick between St Andrews and Glasgow, and then within 3 hours at the open day, I was like, no, this is right, this is where I want to go. And then, but the complete opposite end of the spectrum, I went to my interview at Oxford, and I was like, there's something doesn't sit right, and I couldn't figure out what it was, but it didn't sit right to the point that I was like, if they're the only option I had, I would probably have still gone, but they were certainly not my first choice, and I couldn't quite quantify why. And I think that's...
But you don't need to.
No, I think it's something to be aware of, is that if something doesn't feel right, you don't necessarily need to know why to know that it isn't going to be the right fit.
Other words of wisdom that I got given was ask if you can talk to your future supervisor's current students away from your future supervisor.
And the holy grail is if they just offer that.
Yes. Yeah. If they offer it, or if the students, so with a CDT, sometimes you don't necessarily have a supervisor lined up. Get vibe checks from the students on the supervisors, because there are things that, as when you go for an interview, you're presenting the best version of yourself, a supervisor's going to do the same thing. And that's not to say, like, check that supervisors aren't evil. They're not going to be evil.
Well, some of them.
Like, if... I'd like to think academia can weed them out eventually. But if a supervisor is very, like, we meet very intensely and you present and it's once a month and you're like, no, I need gold stars of affirmation, very short meetings a few times a week. Like, if your work styles clash, they're not necessarily going to tell you that until it's too late. The students will tell you, oh, this guy does this, or this woman does that. Like, they will tell you what the supervisory style is, and also be a bit more honest about it than the supervisors will.
Exactly. So I think if you could sum up, like, the process of getting into PhD, like the best advice you can give for someone who wants to go and do that, what would be the best advice you can give?
I think it would have to be in 3 parts. So first is email everyone. Anyone that looks interesting, get in contact with lecturers, get in contact with training centres. And there's no harm in emailing and just reaching out, being like, hi, this is what I do. I'm kind of interested in what you do. Do you have anything available? Do you know how I can apply for funding with you? That sort of thing. The more people you talk to, they might recommend someone else. They might have something available. Like just get in contact with as many people as possible, even if it's something like kind of tangentially interesting to you. Like there's no guarantee. Well, maybe that's my second point. You don't have to know exactly what you want to do for a PhD before you start. So you can have a very broad idea. So for me, it was like, I kind of like numerics, but I don't want to do heavy computing. And I kind of like theory, but I don't want to do really pure analysis. Somewhere in the middle about a fluids problem that's kind of funky. Like, that's the vibe. And then anything that fit within that remit, I was applying for or looking into more, because there's no guarantee that I know exactly what that means. And projects always change and adapt as well. So you could start off with one very specific description, and as the project progresses, it might go in different directions. You can't know where you're going to end up before you even start. So don't worry about being too set in what you go for. And then final bit of advice is probably the most important, is don't forget that you're interviewing them as well. It needs to be a good fit for you, and you're allowed to be a bit needy and demanding with what you want. They're allowed to tell you to go away, but you're allowed to be picky. And yeah, don't forget that you're better off doing something that you enjoy, that is a good fit for you, than something that will make you miserable and you might have to quit. So I'd say that's my advice.
Nice. Rather comprehensive advice on just about everything.
Yeah, basically. If in doubt, all of the things.
If in doubt, all of the things. Fair. Very fair.
Having just, like, obviously I'm coming at this from like sage words of wisdom. I did this 4 years ago. What fresh off the bat advice do you have? So
I'm gonna mostly base it on the things that I think I should have done that I didn't do as much. The first thing that I would say is, especially if you're UK based, in fact, frankly, if you're anywhere, there are a hell of a lot more universities that do your subject than you think there are. Because I found out actually a lot later, after I'd done all my applications, like, oh, there's stuff at Southampton that would have been interesting. There's stuff at other places around around the UK that would have been interesting to me that I just didn't apply for because I didn't realise they had astro departments. I would certainly echo your point that don't try and pigeonhole yourself too much. Like, this is something that actually got, I was told by an academic at Cambridge when I went for my interview, because I was showing up saying, I don't really have a research area that I specifically want to do. I have a process that I like. I want something, numerical simulations, looking at evolutions of systems, but I don't really mind if it's like star formation or galaxies or the evolution of explanatory systems or something like that. Like, just something simulation was what I was looking for. And what this academic said to me was, in some ways, that's actually you're a really useful sort of applicant if you don't have a clear idea of what it is you want to do yet, because what they were getting a lot of was people showing up to interview at Cambridge and be like, I've done my master's project in exoplanets and in hunting exoplanets, and that's what I want to do for my PhD. Or I've done a cosmology project and I want to do cosmology in my PhD, and they're very like tunnel vision rigid on what they want to do.
Yeah.
And that's not necessarily the most useful thing in the world. Like what I was applying for changed as I was going through. Initially I was only looking at star formation stuff, and then I started looking at galaxy stuff, and now I've ended up on a galaxies project. And there's no harm in looking around, because as much as you're at the end of an undergrad degree and think, I like this, it doesn't necessarily mean there isn't something else out there that either you don't know exists, or you don't know can be interesting to you. So I would say look wide and look outside of that tunnel vision you've had for your project.
Yeah, it's that first peak of that graph that we were talking about at the beginning.
Yeah, the Dunning-Kruger.
You leave undergrad and you think you know everything about the research field, and it's like, actually there's so much there that you don't even begin to know that you don't know.
I'd never heard the phrase circumgalactic medium, and now I'm going to be doing a PhD on it. It's not a topic I knew existed.
Sounds
Circumgalactic medium being all the stuff around a galaxy.
No, that makes sense. Okay.
Like, I didn't realise that was an entire research field from doing my undergrad, and now I'm going to go into a PhD in it. There's going to be so much stuff that you don't realise exists. So have a look around. Talk to academics. If you're doing your bachelor's or your master's, talk to your supervisor and say, I'm looking to do a PhD. I'm not really sure what I want to do. Is there places you'd recommend looking? Are there things I should be looking for? I mean, I hadn't really, like, Cardiff wasn't on my radar initially when I was looking for stuff.
Yeah.
And then my supervisor said, oh, Cardiff's got a really good department for astro. I'm like, oh, I'll have a look. And like ended up applying. And
yeah,
it takes that sort of thing. Look wide, talk to people, and don't just pigeonhole yourself too early. That's probably my advice based on interviews and not having done a PhD yet. I think that's probably a good point to end on, is that there is so much out there. It just takes taking that step to go and talk to somebody. And yeah, it might be a pain to go and actually go and talk to them in person, and that's nerve-wracking. But like,
people are scary.
People are scary. But honestly, academics and Twitter, like you can drop people emails.
Yeah.
You can honestly DM people on Twitter that are in the field you're interested in, and be like, they might not have someone, but they might know somebody that or know someone to go and have a look. So it's always a good idea. Just it can never hurt making that connection.
Yeah. Final teeny tiny bit of advice as well. If you're gonna email far and wide, try and make sure it's personal, and also remember that people don't owe you a reply.
Yeah.
Just to curb expectations slightly is these people are real people too.
And they get far too many emails.
They get far too many emails. And sometimes they email you back after you've started your PhD saying, hi, Kat, really sorry, but if you're still interested in doing something in Manchester, I'd love to hear from you. Thank you. I'm okay. But,
well, I got an email from somebody today saying, oh, sorry, that position's been filled. I was like, it's fine, I've got a place at Cardiff.
Yeah.
But anyway,
things happen.
Yeah, I think that's probably a good place to end.
This was fun.
Thank you everyone for listening or watching. I realize it's audio and podcast, but where can they find us?
We have a Twitter.
We do.
We have an Instagram, and I looked at the titles, the handles.
Yep.
I definitely know these.
It's fine. On Twitter, we are at Unstable Fluids. Or is it Unstable Fluid or Unstable Fluids? I think
it's Unstable Fluid.
It's Unstable Fluid on Twitter, and then on YouTube and Instagram, we are at Unstable Fluid Podcast. And then you can email us, unstablefluidpodcast@gmail.com, if you want to email us.
You can also shout into the void, but there's no promise that we'll reply.
Exactly.
Yeah.
You'll find us.
Yeah. And Thomas will probably reply because I am not in charge of anything. So
if you have a specific question for Kat, tell me and I'll relay it. Anyway, thank you for watching and listening I don't know. It's been good fun.
Both.
And we will see you in the next episode of
the next one.
The Unstable Fluid Podcast.
Bye.
Bye.